Normally, we use conventional type of cylinders which you would find in your homes, restaurants, and other small commercial establishments. In these cylinders, LPG is stored under pressure as liquid in the cylinder. The liquid is converted to vapor naturally inside the cylinder at ambient temperature and is discharged out through a VOT cylinder valve and used for fueling burners. The rate at which liquid LPG inside the cylinder is naturally converted into vapor LPG and discharged for usage is around 400 to 700 grams per hour per cylinder. Our customer, Mr. Sundar, was using 6 burners in his hotel's kitchen at a time. His cooks often complained about inefficient burning. They called it low pressure in the burner flame. When I visited Mr. Sundar's premises, I noticed that the LPG cylinders and pipes were frozen, and the kitchen staff kept pouring hot water on it to defrost. So, how did this happen? Let me explain. In Mr. Sundar's kitchen, 6 burners were burning. Now, the smallest of these burners have a heat output of 46,000 BTU per hour. On an average, 1 kg of LPG is required per hour per burner. 6 burners will require at least 6 kgs of LPG per hour. Say for instance, you have 2 cylinders connected in a manifold through which 6 burners draw LPG from manifold. And the burners altogether would require 6 kgs of LPG per hour. With the 2 cylinders connected, the manifold will naturally convert a maximum of 1.4 kgs of LPG vapor per hour to be discharged from the cylinder. Now, since the burner ends up withdrawing more than vapor LPG output from the cylinder, the liquid LPG tries to draw more heat from the walls of the cylinder, which makes the cylinder colder. It is this imbalance of vapor pressure that causes freezing or frosting. The only way to stop the freezing is to connect more number of cylinders to the manifold so that sufficient LPG can be given to the burner. So, for 6 burners, 12 to 14 cylinders need to be connected to the manifold. What will happen if you do not connect sufficient number of cylinders? Firstly, the burner will not give you the rated heat output because of insufficient LPG. Secondly, if the vapor pressure in the cylinder drops, it will cause condensation and freezing, which will make it impossible to withdraw LPG from the cylinder. And this is why at Mr. Sundar's place, his staff poured hot water, which is an unsafe practice to heat the cylinder. But this solution of adding more cylinders will raise the issue of space and handling of more number of cylinders. So, we suggest LOT. LOT, liquid offtake cylinders. LOT was introduced as a solution where space is an issue and also a hazard of handling large number of cylinders. In case of LOT, liquid LPG will be drawn instead of vapor using a liquid offtake valve, and this is supplied to burners through a specially designed vaporizer which converts liquid LPG to vapor. LOT makes it possible to discharge about 4 kgs of LPG per hour per cylinder. This way, the number of cylinders connected to manifold can be reduced. So, liquid offtake LPG system would give burners enough LPG to produce efficient heat and also makes it simpler as the space required and number of cylinders to be handled will be less. Flow-right LPG liquid offtake systems. Flow-right LPG liquid offtake systems are designed to provide a constant flow of LPG as per the requirement of any burner to output efficient heat. Liquid LPG will be drawn instead of conventional vapor using a liquid offtake valve in the cylinders, and this is supplied to burners through a specially designed vaporizer which converts liquid LPG to vapor.